Salam and welcome everyone. So today we're going to be working on the question on the screen that says a possible wave function for an electron in a region of length L, that is from x equals to 0, is sine 2 pi x, normalize the wave function to 1. Now, this question is from the Atkins Critical Chemistry 11th edition textbook in chapter 7a. We're told to solve by normalizing the wave function to 1. Now, the first thing you have to do is we're going to write out the parameters we're given. We're told the possible wave function for an electron in a region of length L from x equals to 0 to x equals to 1. So the entire length would be from x equals to 0 to x equals to L. Sorry, not x equals to 1, x equals to L. Just think about it like a ruler. A 30 centimeter ruler is just 30 centimeters. That's from 0 to 30 centimeters, right? And then we're told that the wave function is, which is psi. By the way, psi is a Greek letter that represents wave function, not wavelength, sorry, wave function in calculus. Or yeah, so basically this, or in quantum mechanics. Anyways, the wave function psi here is this one right here, which is sine 2 pi x divided by L. And we're told to normalize the wave function. In order for you to have a normalized wave function, your final answer has to be in terms of n, which is a normalization factor, times the wave function. So this is a normalized wave function. It takes this form, n times the wave function. And you're going to be wondering, what is n? N is what you call the normalization factor, okay? Or you can call it the normalization constant. Now, what this is telling us is our final answer is going to be n times the wave function. That is how we are successfully normalize it to 1. But the issue is that how do we determine what the value for n is? Because when we find the value of n, we can just say n multiplied by sine 2 pi x divided by L. In order for you to be able to determine that, we have to first of all know this from the concept. The probability of finding a particle, or let's not even say finding, the probability that a particle in the region, the probability that a particle is in the region dx is equal to n times the wavelength, okay, squared, which is equal to 1, where n is a real number. Now, you're going to be wondering, okay, this is a lot of information here. What this is just telling you is the probability that a particle is in the region dx is equal to n times the wave function all squared, which is equal to 1. Now, think about it this way. Imagine I have been to 50 different countries in the entire world. Now, and imagine for whatever reason, somebody is trying to locate me in the 50 different countries in the entire world. The probability of me being in one of those 50 different countries that I've been to in the entire world is 1, because there's only one of me. I cannot be in two places at once, just like a particle cannot be in two places at once. It can only be in one particular place at a time. So that is what this is saying. Imagine that in a region, dx, imagine dx is the entire world. The probability of finding me in the entire world, whether I'm alive or dead, is 1. I cannot be found in one place. So this is basically what this is trying to tell you. And to think about it mathematically, we end up getting the wave function, okay, n times the wave function all squared dx is equal to 1. In your physical chemistry articles 11th edition textbook, you can end up seeing it as n squared, and then you have the integration symbol. So this is the integration symbol. This is basically reminding you guys of calculus, right? Calculus 2 especially. Anyway, so you have the integration symbol. You can then bring out the n squared, because this is how you see it in the Articles Physical Chemistry 11th edition. So times the wave function x times the other wave function dx. Just note that it is basically the exact same thing. Wave function star and wave function is basically the same thing. They are just trying to differentiate it in the textbook. So all of this information is going to equal 1. So this is how you may see it in your textbook, but I like to write it like this. I like to write it in that way. I don't need extra information. I already know I'm gonna square them. And yeah, that's basically it. So yeah, and when we do this, we can actually solve for the value of n. So let's remember now, n is n, which is what we're solving for, and the wave function is sine 2x divided by L. So we're going to integrate n, okay, times sine 2 pi x divided by L, all squared dx is equal to 1. But when you go back to our question, like I always say in a lot of my videos, is that you have to remember from what range to what range. We see that we're dealing from x equals to 0 to x equals to L. So x equals to 0, you get to x equals to L. You see that here is going to be equal to x equals to 0, x equals to L. Going back to the example I already explained to you guys, right? I said I've been to 50 different countries. Even though a region dx, we are in a situation where we're supposed to look at a specific region within the region dx, right? So imagine you're looking for me and they're like, well, she's been to 50 different countries on her passport. Rather than looking at all the over 200 plus countries that exist on Earth, let us just focus on the probability of finding her in those 50 different countries or locating her in 50 different countries. So that is basically what this is right here. So in the region X over L. Anyways, this is it. So now we can start our work. So when you rewrite this, you can actually just have it as n squared sine squared 2 pi x over L, okay, dx. So this is what this is equal to 1. We already know, they told us normalization constant is a constant, and we know in our rules of integration, you can bring out the constant in front. So that would be n squared, you bring that out. So that would be x equals to 0, x equals to L. So that would be sine squared 2 pi x over L dx is equal to 1. Now, I want to quickly mention something. Sine squared 2 pi x over L, if you try to remember in calculus, you would realize that you cannot actually integrate that. But in mathematics, generally, we know that if we cannot solve a particular thing, we can either we simplify it to make it easier for us to solve, or we substitute it to an equal value of what we're trying to solve for to make our work easier to solve. So basically, what I'm trying to say is, since we cannot integrate sine squared 2 pi x over L, we have to look for a function that is exactly the same as this function and substitute it and make sure that we can integrate that function. Now, because of this knowledge, I'm going to take you back to trigonometric identities. So trigonometric identities, one of the identities is just sine squared, okay, 2x is simply 1 over 2, open bracket, 1 minus cosine of 4x. When you look at this trigonometric identity, you can use this to substitute over here. So when we do that, I can just end up with, I'm going to rewrite this, sine, okay, squared of 2 pi x over L is the same thing as 1 over 2, open bracket, 1 minus cosine 4 pi x over L. That is just basically what this is. This is it. So I'm going to substitute here. So that would be n squared, x equals to 0, x equals to L, and you have 1 over 2, 1 minus cosine 4 pi x over L. So that is basically this one. And then of course you have dx equal to 1. Going forward, I'm going to ignore equals to 1, and I'm going to put it at the very end because I don't want our work to be too much information at the same time. We should be able to do things one thing at a time. So going forward, I'm just going to be focusing on integrating this, and then at the end I can say equal to 1, right? So that's how it's going to happen. So next, we can bring out the 1 over 2 because it also is constant. So we have n squared divided by 2, and then the integration over x equals to 0 and x equals to L. So that would be 1 minus cosine 4 pi x over L, okay, dx. Okay, so that is it. And of course, n squared over 2. Now we can start our integration. When you integrate 1, you end up with x minus when you integrate cosine 4 pi x over L, you end up with sine 4 pi x over L. But then we are mathematicians as well. We know that if we integrate cosine x, we get sine x. But if we integrate cosine 4 pi x divided by L, we end up with sine 4 pi x divided by L times the integrated value of, sorry, divided by the integrated value of um 4 pi x over L. So divided by 4 pi x over L prime. So that is basically what we're going to do. So this is going to be in a range x equals to 0 to x equals to L. So anyways, you end up with n squared over 2 x minus 4 pi x over L. Okay, when I do the what's it called? When I do the what's it called? When I do the I'm sorry, the differentiation. When I do the differentiation of that, I just end up with minus sine 4 pi x. Okay, I'm just rewriting that one. Okay, divided by 4 pi over L, because integrating 4 pi x over L is just going to give you 4 pi over L. So divided by 4 pi over L. Okay, from range x equals to 0 to x equals to L. So rewriting this, we end up with n squared over 2 x minus L divided by 4 pi sine 4 pi x over L. Okay, from x equals to 0 to x equals to L. So yeah, we already know from doing integration, we already know what we're supposed to do next. We're just simply supposed to substitute, right? We're going to substitute x equals to L as well as x equals to 0. So doing that, you have n squared divided by 2. We substitute x equals to L the first place. You have L minus L over 4 pi sine 4 pi, and then you substitute x for L, so that's 4 pi L divided by L, okay, minus, you substitute x equals to 0, so that's 0 minus L over 4 pi sine 4 pi of 0 divided by L. So basically 0 times 4 pi over L is just 0, so I don't need to like write that. Don't have to substitute everything like this step by step. Anyways, yeah, let's rewrite. So that would be n squared over 2 L minus, sorry, yeah, sorry, L minus L over 4 pi, and then you have sine. So here you see, cancel out the L here, cancel out the L here, so you end up with sine 4 pi, okay? So I'll simplify our work, minus 0 minus L over 4 pi, sine of 0. Sine of 0 is just 0, so everything here will just be equal to 0. So I'm just going to say minus 0 here. So that's it. So that would be n squared over 2 L minus L over 4 pi. Sine of 4 pi is the same thing as just simply 0. When you input down your calculator, you're going to see that. So all of this here also goes to 0. So what you end up with is n squared divided by 2 times L. So n square L divided by 2 is what we have. Now you're going to be wondering n square L divided by 2. Don't forget that we're told to normalize to equal 1, as well as the probability is going to equal 1, right? It's going to equal 1. So, and I know that I stopped doing equals to 1 just because I don't want our work to be filled with unnecessary information. Now I can put it here and say it's equal to 1, and we're going to solve for n, the normalization constant or the normalization factor, whatever you want to call it. So cross multiply, we end up with n square L is equals to 2. Solve for n, divide both side by L, divide both side by L, cancel L here. So that would be n squared divided by 2L. We square it both sides. When you square both sides, you end up with end up with n is equal to the square root of 2L. And this is basically the answer to the normalization factor or normalization constant value. Now, let's not forget, they said we should normalize the wave function. The normalized wave function is just n times the wave function. So let's not forget, our work is still not done. Normalized wave function is just n times the wave function. So our answer or final answer would just simply be the square root of 2 over L times the wave function, which is just sine 2 pi x over L. And this is basically the answer to this question. Perfect. It is the square root of 2 over L sine 2 pi x divided by L. So if you have any questions, suggestions, or concerns, make sure you put it in the comment section. For those of you who are confused as to how I solve this, I did another question on my channel, which is a possible wave function for an electron in a region of length L is sine 3 pi x over L normalized to the wave function. So this is just another question, very similar to this one. And I would implore you guys to please go and watch it. And if you're confused as to how I solve this, make sure you watch this video. So if you have any questions, suggestions, or concerns, make sure you put in the comment section. If you want to help me grow this channel so that there will be other students who will succeed, get the best value from my content, make sure you share it with your classmates and also make sure you subscribe. If you want me to do other problems from questions that are not from the Articles Physical Chemistry 11th edition, also email me. And if you're a student who is struggling in any of your STEM related courses, whether you're in middle school, high school, or college, I'm the tutor for you. I help students succeed in all their STEM related courses. And if you want to succeed in any of your STEM related courses, by my way of tutoring you and mentoring you, make sure you email me at shahabitutoring@gmail.com. I'll strive to help you with the best of my capability. So I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.